We move to the part 2, the writing part of the EOT. The 16th question is problems on optimization. They're all real world problems. I would highly encourage all of you to read the problem and understand what it means. I will read it out now. A three-sided fence is to be built next to a straight section of river which forms the fourth side of a rectangular region. The enclosed area is equal to 1800 feet square. Find the minimum perimeter and the dimension of corresponding enclosure. Remember, this is the writing part. You need to write everything in detail. So first thing what I would suggest is draw a simple diagram to understand better. Now they have told the fourth side is there is a river which is a straight river. Imagine that's a river. You're building a fence and one side of it is the river itself. So you will just build it on three sides. Okay, that's not straight, but just imagine this is a straight line, straight line, straight line. This is a fence you're building. Now here, how I've drawn is a vertical river, and this is the horizontal length x, x, and y. Now imagine if you have drawn a river like this and you drawn the fence like this. That is also fine. It's just that you will have y, y, x. Both is fine. You will get the final answer to be the same. Now let's try solving it up. What is given? Area is given. Whatever is given needs to be written first. What is the formula of area? Area will be equal to length into breadth, and since over here x and y is taken, the two dimensions will be x times y. Here x, y. Doesn't matter we don't have the fourth side, the area will be the same. See, this is the area, right? The enclosed area, it will be the same, x times y. Now we know area is 1800, so we have x times y. Why do we need this is, we will write this area in terms of a single variable. In the sense y, we will leave it over here, take x to the other side. So it will be 1008 divided by x is equal to y. Now we got the area. From the area equation, we can write y is equal to 1800x. Why did we do this? Because they have asked us to find the minimum perimeter. Now what is the formula of perimeter? Perimeter is 2 times length plus 2 times breadth. But here it's just a three-sided fence, right? So how many x's are there? It is 2x plus y, or you can take it as 2y plus x. It's fine, you will get the same answer. And what do? Here you can't differentiate. See, you need to find the minimum. Minimum or maximum means you need to derive this and find the critical numbers. But here, since you have x and y, it would be implicit derivation and it will be very complicated. You won't be able to solve it. So what we do is we write this y in terms of x, right? We will substitute over here now. We will get p is equal to 2x plus y would be 1800 by x. Even over here you could do the same thing, it's fine. It's just that the when you solve it, the answers will be the same, just the methods will be different. You can try this by yourselves. Now here what happens is only one to do, not both. I'm considering this one and I'm solving it over here. Now what happens over here is you need to derive this p dash. It's all with respect to x, so it will be just 2. And now what is the differentiation of 1 by x? 1 by x can be written as x to the power minus 1, and it would be minus 1 times x to the power minus 2, because we have to do power minus 1, power rule over here. And this can be rearranged and written x by 2 squared. Why? Because this goes down, it will be positive power. Now instead of doing this all the time, you can easily remember the formula for 1 by x derivative is minus 1 by x squared. Here 2 minus this plus becomes minus 1800 constant divided by x squared. This is the derivation we get. This is 2. Okay, 2. And now what do we need? We need to find the critical numbers. How do we find critical numbers? Is equating this is equal to 0. And now we get 2 minus 1800 by x squared. You can just take this to the other side and solve it up. It will be 1800 by x squared equals 2. Swap these. It'll be 1800 by 2 equals x squared. 1800 by 2 is 900. You need to take square root on both the sides. Square root over here will be 330. X will be plus or minus 30. So this is the answer for x. Now here there is an important thing which you need to know. X cannot be negative number. Why? Because we are dealing with the real world problems. Here there is an interval x must be greater than 0. Okay, and over here look, it's divided by x. You cannot have x equals 0 as well. I can't write less than or equal to y. It would be undefined here. That wouldn't make sense. So x must be greater than 0. This is a condition. Just by looking at this problem, you should understand. And since it's a width, you're considering x to be equal to positive 30. So that is the x value we got. And there are no endpoints over here. X can be greater than 0 until any point. So that's fine because we have no clue what is the x, right? So now we need to find the minimum perimeter. In fact, in almost all the problems, we can just take this as the minimum perimeter value. So x must be 30 and then you can find y. But before we do that, we have to just double check whether this is true. What do I mean is double check whether this is the minimum perimeter. So there are various ways. You can do double derivative test, or I will just stick to single derivative with the number line method. If you do this, it's more than enough to check that that's the minimum perimeter. I just erase this part now. Now, over here we have this p dash we just now derived. Now we need to do a number line. Just draw a straight line and write the x value. Now since it's not plus or minus, we have concluded that it must be positive number, so it can be only x is equal to 30. That's the critical number. And you can just choose any value less than this, but avoid 0 because that will be undefined. So I'll take 1, any number less than 30. You can take 29 as well, it's fine. And take any value more than 30. I'll just take 31. I'll take a easier number. 50 is easy to calculate, or 100, so you can take anything, so it's up to you. And now what you need to do is substitute these values in the derived equation. See, this is for p dash of x. Okay, this number line, the first derivative test. Here, substitute this number over here and check whether you're getting a positive or negative value. So when you substitute 1 back in over here, what happens is you will have 2 minus 1800. It will be a negative number, minus sign, so it's decreasing. Now, whenever in the first derivative you get negative over here in this number line, this means it's decreasing. And what about if you substitute 100? If you substitute 100, it will be 100 squared is 10,000. Then it will be 10,000. 1,800, it's less, so it will be obviously less than 1. So it will be a very small number basically, and it will be positive over here, okay? Because it will be 2 minus a very, very small number is a positive number itself. You can just put it in the calculator and check it. Don't do like, if you're getting confused, just put in the calculator, you will get the answer. So here we can see it's a minimum point. So x is equal to 30 is minimum. Okay, this is the way to prove it. And now once you have done this, we can conclude that x would be the minimum most. If you use x dimension as 30, that would be giving you the minimum perimeter. So what do you want to find? Y as well, right? So what is y? Y is equal to 1800 by x, which means it's 1800 by 30. This 1 times, this is 6 times, and 0 remains. It will be 60. This is the y value. So we can conclude saying for minimum perimeter, we need to have x, that is the length, as 30 feet, I believe, yes, feet, and y has to be 60 feet. This would be the answer. Now I have not written the steps. This would be the first step, and the second step would be the derivative part with the perimeter. This number line would be the step 3. Okay, there are only 3 steps. Please try to draw a rough figure. It will be much better to understand and solve it up. You can see here, these are the dimensions, 30 by 60. The worked out solution is also available. You can go through this. And over here we have again the same type of problem. The only difference over here is they have told the perimeter which is available. Now, I have done the entire lesson explanation, and the similar problem is done in that, I believe, where the perimeter is given and you have to maximize area. Try it by yourselves and then refer to the solutions over here. And now, this one, I will solve it over here. The thing is, if you look at this, a two-pen coral is to be built. What exactly is two-pen coral? It's something like this, a place where you can, um, protect the sheeps or cows or something like that, where it's two joined enclosed places. Okay, it's basically like one rectangle and one more rectangle joined together, and they are same, equal. Okay, this is a two-pen coral. Now this is to be built. The outline of the coral forms two identical adjoining rectangles. They are mentioned. It is not always the same sign, but same size, but they have clearly mentioned it's two identical rectangles. If there is 120 feet of fencing available, that means perimeter is told. Perimeter is how much? 120 feet. What dimensions of the coral will maximize the area? Needs to be maximized. In this case, what you need to do is basically write the perimeter formula first. Perimeter is, now this is important. Is it 2 times x plus y? It is not this formula because it's a two-pen coral, right? So it'll be basically similar to this. I just draw like this, and over here middle, it's another line. So now if I consider the horizontal distance as x, x and x, this vertical distance will be y, this entire length, and this will be entire length y. Now the perimeter over here would be 1, 2, 3x plus 2y. This is the perimeter. And what is the perimeter given? It's 120 is equal to 3x plus 2y. And now you can easily solve it up. But first thing, you need to rearrange and write y in terms of x. That means take 3x to the other side. It will be 120 minus 3x plus is equal to, 2y equals 2y, and divide both the sides by 2. You will have 60. 120 by 2 is 60 minus 3 by 2x equals y. So now we found out y. This is the y value. Now we need to maximize area, isn't it? So this is the step 1. Now step 2 would be writing the area formula, that is x and y. That's it. Because x into y would be the enclosed area. Over here, area would be x times, what is y? Y is 60 minus 3 by 2x. That's it. That's the. Now, what you do is multiply this x inside. Don't derive it directly. It will be a product rule. It's a bit complicated. I mean, you can go ahead, but you will just save time if you multiply this inside. It will be 60x minus 3 by 2x squared. And over here, when you derive this with respect to x, obviously, it'll be 60 minus, this 2 comes down, it'll be, this cancels, it'll be 3 times 2 by 2, right? This reduces, so this cancels. So you will have 60 minus 3x. This is the derived equation. Now, to find the critical number, you need to equate this to 0 and now solve it up. Take this 3x to the other side. It will be 3x is equal to 60. X will be equal to 30 by 3 will be 20. So x is 20. Now let us do the step 3 to check whether this is the maximum enclosed area. We need to maximize the area. So let's do the number line. Here it is 20. Oh, by the way, x must be greater than 0 no matter what. Otherwise, this would not make sense because it must be a positive number. There is no n interval, so we'll just take this as derived one, this one. Okay, now whatever the value you get, you put in the derived equation. So all you're going to do over here is take a value. I will just take 0 because it's not undefined anyway, right? Yeah, it's not undefined anyway. So I will just take 0, less than 20, and more than 20, I'll just take it as 50. It'll be easier. And now what you do is substitute the 0 in the derived equation. If you substitute over here 0, it's going to be positive. Why? This term becomes 0, right? Over here is much easier. This term becomes 0, you will have only positive value. It's increasing here. What about 50? 50 times 3 is negative 150, but minus sign makes it minus 150 plus 60, which is basically negative 90. So it's minus. We are not interested in the value, we are just interested in the sign. And this is the thing. X equals 20 is maximum value. And now you have the x value already, substitute and find the y value. Y is equal to 60 minus 3 by 2x. That means it's 60 minus 3 by 2 into 20. 1 time 10 times. It will be 60 minus 3 times 10 is 30. It's 30. Y is 30. So you will have maximum area when the dimensions are 20, it's feet, 20 feet by, sorry, x is 20. It's 20 by 30 feet. Okay, 20 feet by 30 feet. So that's the answer. So this is how we solve this problem over here. And let's just look into the solutions as well. Um, yeah, everything is right. But look over here, I had taken 3x. Okay, I had taken x, x, x. I taken like this. But over here in the solution, it's same. The answers are same, no problem. It's 20 by 30. But what they have considered in the figure is like this. So what happens is they have taken x, this entire thing as x, and bottom as x. So you have 2x plus y, y, and y, 3y. Even if you do like this, you will get the same answer, no problem. It's just that, this equations will be a little bit different, but it's all right. You can follow whichever you're convenient, whichever is easy for you. And now we have the box problem. No, sorry, it's not the box problem. I thought it was a box problem. This is about a showroom. Let's read this problem. A showroom for a department store is to be rectangular with walls on three sides. Okay, the three sides only has walls. And then 6 feet door openings on two facing sides and 10 feet door opening on the remaining wall. The showroom is to have 800 feet square of floor space. What dimension will minimize the length of the wall used? It's just a little bit of difference and then it's all the same. Now, if you're finding this is all too long, you can, continue solving all these videos by yourselves. But since I'm finding these are all, different type, I'm going to solve it anyways. But you can just skip forward or you can just skip the video if you've understood thoroughly. Try to solve these by yourselves and just go ahead. Now, how do you solve this is, first let's draw a simple diagram here. So I will, it's a open, see, a showroom, right? There's an opening. It's kind of like this, okay? Just imagine this is the opening. Obviously, it'll be much bigger, but mine, okay, just understand these are the walls. Now, in these walls, if you consider this to be X, okay, and this is also X, then this is Y. What has happened? There is a 6 feet door opening, so you need to remove that. So it'll be X minus 6 feet over here. Same thing over here, x minus 6 feet, and over here it will be y minus 10 feet. They have clearly mentioned it. 3 walls only, and these are the door opening, okay, on the remaining of wall. So, yeah. What dimensions must minimize the length of wall used? We must minimize the length of wall being used. The area is given. The floor space means all this region, right? That's basically the area. So, how do we solve it is, first of all, we need, it's not the perimeter exactly, these sides, right? Because over here, we are removing the, the sum part. Let us write it in terms of length will be equal to y, there's only one y plus 2x. I hope this is clear. But this is the actual one if it was just walls without the doors, okay? It's like the perimeter only. You can consider this to be perimeter, it's fine. But here, what is the problem? There is some changes in this x and y. So L is equal to y becomes minus 10. And what about x plus 2 times x minus 6? Now we need to solve for length. Because here we can see here the area is given, right? So let's write the area formula first. A is equal to 800. So what is area? Is x times y. But here, do we have x and y? No, we don't have x and y, right? What do we have? We have basically x minus 6. No, what you can do is let's consider x and y itself, okay? Because what we will, it's easier to keep it as x, y, x only now. And I'll just rearrange this. 800 is equal to x, y. And what is y? Y will be 800 divided by x. Now, this is just a simple rearrangement. Now, y is found out. Now, let's find the length, the perimeter, or I'll just write it as length. What is the length? There is 2x, x plus x. I'll write it 2x plus y. There is y1 length, then the open side, right? Here now, what I'll do is, I will write x minus 6. Why? See, for area, you can't write x minus 6 because area is this entire length, even including the door, the door space as well, because it's a floor area. But for the length, it's not like that. For length, x is basically x minus 6 because you have to remove the door area, door, whichever the space for the door, right? Because you're just doing the wall without the door, right? So that's why we use x as x minus 6. So x minus 6 plus y will be y minus 10. Now you basically multiply this 2 inside. It will be 2x minus 12 plus y minus 10. And now here, this is L. Now just try to rearrange. Oh, before we can simplify this. What you can do is take this to the other side. It'll be 2x. No, don't take it to the other side. Sorry. Solve it. Plus y minus 22. Now substitute the y value. Y is plus 800 divided by x minus 22. This is the length which we got. It's all with respect to x now. Now derive it with respect to x itself. You will have 2 minus 800 by x squared. If you're thinking why, we just did it some time ago in the video. That's why. And this will become 0, so don't write it. Now this is the derived equation. Now we have got, this is just to write y in terms of x. Now we have got the derived one. This is the length. Now they have asked to minimize the length right over here. So let us just check whether it's minimum or no. Oh, sorry, before that, you need to put this as 0 and solve it. Okay. So what happens is here L dash derived one will be equal to 0, that is equal to 2 minus 800 by x squared. Take this to the other side, it will be here. What happens is it will be 800 by x squared equals 2. Now change it over here, it will be 800 by 2 equals x squared, cancels, it'll be 400. What is the square root of 400? It's 20. So x is plus or minus 20. So this is the answer. These are the critical values. But we know x cannot be negative. X must be greater than 0. So x will be positive 20. Remember, x cannot be 0 because it will be undefined over there. It should be a positive number or greater than 0. So here it is 20, take a value less than 20, that can be 1, and over here it can be anything like 50. And now this is L dash of x. Do the same first derivative test and check. Over here is the derived. Where is the derived? Over here, this one. Substitute 1, it will be 2 minus 800, it's a negative. And when you put 50, 50 squared is a huge number. It will be less than 1 for sure. So it will be 2 minus a small number is positive. So it will be minus is down and up. So x equals 20 will be the minimum value. And yes, this is proven. It's the minimum length now, whatever you find out. And what is the y value? Over here, y equals 800 divided by x is 20, right? Now solve this, it will be 40. So y equals 40. When you have the dimensions of x equals 20 and y equals 40, you will have the minimum length for the wall. So this is how we solve it out. You can see here it's 20 feet and 40 feet. So this is how we solve this problem. And now we have a couple more problems. It's all proving show. So I will just explain these over here itself. Now show that the rectangle of maximum area for a given perimeter P is always a square. Now this is again a simple problem. Let me just solve it up. Let me write it and solve it up. Because over here there is no area, no perimeter. This is a different type. So what you need to do? See, first let's write the area formula and the perimeter formula. A is equal to xy. Perimeter is 2x plus 2y. We can't write anything in terms of y. We need to look here. They have told maximize area, maximum area. So this needs to be derived. Leave this. Now rearrange this in terms of y. So what do we do is take this 2x to the other side, be p minus 2x equals 2y. And see, it's just like how we solved previous problems, but it's just that they have told maximize area where perimeter is p. That's it. P is the perimeter. They have not given a value. There's no constant value. Imagine this is a constant. That's it. And now it will be p by 2. Divide both the sides by 2. It will be p by 2 minus x is equal to y. Now substitute this y over here. A equals x into p by 2 minus x. And now multiply this x inside. It will be p by 2x minus x squared. Now derive the area. We need to find this maximum area. So it will be p by 2 minus 2x. So I hope this much is clear. It's very basic till over here. Now, what do we need to do is find the critical number. We need to put the area derived is equal to 0 and solve for x value. So take this to the other side. It will be 2x is equal to p by 2. 2 to the other side. In the denominator, it will be x is equal to p by 4. So the critical number over here is p by 4. Now what you need to do is, here we don't have any way denominator as x, right? So x must be greater than 0 for sure, because we don't have in the denominator. I'll take, now to prove it, let's do the number line. Sorry, that's a crooked line. It's slanting down, but anyways, x is p by 4. Any value less than p by 4. You can take it as p by 8. It's fine because it's less than p by 4. You can take 0 because it's not undefined anywhere, right? I'll take 0. What is value greater than p by 4? P by 2 is greater. I'll just take, wait, 1 second. Yeah, p by 2 is possible, but I will take p itself, okay? You can take p by 2, p by p, 3p by 2 or anything like that. Greater than p by 4. And what is this area? So what you do is, look at this number and see what has happened. Where is the derived equation? This one. Substitute over here. When x is 0, what is the value over here? X is 0. This is gone. You will have p by 2. We have considered p as a constant value. It's a positive number, right? So it's going to be positive over here. Okay. And then what if this is p? So let me solve this. P by 2 minus 2 times p. It will be p half minus 2. What is half minus 2? It's 3 by 2. It's 1.5, right? 1.5p, 3 by 2p. Now this over here, sorry, negative. I forgot. Minus 2 plus half is negative 1.5, isn't it? You can just do 1 by 2 minus 2. That is negative 1.5. But we have p in both sides, so we write p over here. Okay, you can write p outside. So it's minus 1.5p. So it's minus here. This is plus minus. So what happens? It increases, decreases. So it's maximum area, right? So at p by 4, we get maximum area. So well and good. We got x must be p by 4. Now what is the y value? Substitute back over here. Where is y? This one. Y is equal to p by 2 minus x is equal to y, isn't it? So now substitute it back over here. What happens? P by 2 minus p by 4 is equal to, I don't know why I wrote it again. Anyways, so p by 2 minus p by 4 is how much? Again p by 4. Here you can see x is p by 4, y is p by 4. So whenever you have to maximize the area for a given perimeter, you get the dimensions equal. So it's basically the same dimensions, as length and width is same. So it is always a square. What is square? X and y is equal, right? In square, we got x and y equal. So hence we can conclude it's a square. So these are the steps, okay? See, follow the steps what I've written initially, step 1, step 2, step 3. I'm now writing it all of a sudden. I'm thinking that you understood the concept. Now we can easily solve them up. That's why I'm writing it directly. You can see the solution is also about that. It's basically you'll get the dimensions p by 4 and p by 4. That's why it's a square. Now over here, again, the same concept, minimum perimeter. It's just that we have to find the area in terms of y and then derive perimeter. Please do this by yourselves. It's the same concept. It's just the other way around. Try it by yourselves and then check the answer. Over here, all the explanation is there anyways. It's again a straightforward problem. Please check it later. Over here now we have the box problem, folding. Let's do this one. A box with no top is to be built by taking 6 inches by 10 inches sheet of cardboard, cutting x inches squares out of each corner, folding it up the sides. See what happens is you're cutting a square. Let me just draw a square over here, and you're cutting a square at each corner and then folding this up, this side up over here, up over here, up over here, up over here, and this is how you form this box. We need to find the x value that will basically minimize the volume of the box. Here all you need to do is the volume formula. This is easier. Why? Because we are not having two formulas. Say the first formula, then we need to solve it again. No, it's just one formula over here, so it's much easier. Now what do we do is, let's write this length. Since it's a little bigger, I'll take this as 10. And over here, x initially it was like this cardboard, right? Okay, this is a very bad cardboard, but a square of x, see, this is also not even, but it's all x, x, x that's been removed. So if this originally length was 10, 2x is removed. It will be minus 2x. This length will be 10 minus 2x. Okay, so what we do is write this dimensions as 10 minus 2x because 2x's are removed, and here also it will be 6 minus 2x. Now the volume is length into width into height or thickness, so volume will be length, I'll take it as 10 minus 2x into width is 6 minus 2x, and lastly height is x. That's it, that's the thickness, right? Now let's solve it. You can do x multiplied over here and then multiply, or I'll do like this. First the FOIL method. These two terms, it will be 10 times 6 is 60 minus 20x. Then this term over here will be minus 12x minus and minus will be plus 4x squared multiplied by x. Over here you can simplify. Look, it will be 60 minus 20 minus 12 will be minus 32x plus 4x squared. All things multiplied with x. This is x. So now multiply the x inside. It will be 60x minus 32x squared plus 4x cubed. This is how we get. This is the volume with respect to x. Now, how do we find critical numbers? Very simple. Derive this. So when we derive it, we'll get 60 minus this x square, right? 2 comes down. It will be 32 times 2. It will be 64x plus 3 times 4 is 12x squared. This is the answer. Now you just have to equate this is equal to 0, and I'll write the highest degree first. 12x squared minus 64x plus 60. Now, how can you find the x values? This is a quadratic equation. Use your calculator mode phi 3. Let's click on mode phi and look over here. Quadratic is 3. And put the first coefficient before x squared, it's 12, and then we have minus 64, and lastly we have 60, and the answer is 4.12, and we have got 1.21. So let me just write it. X is equal to 1.21 and 4.12. Now which do we select? There is an important step. Now this can be considered as step 1. Okay. Till over here, the derivation can be considered as step 2. Then there is an interval. So what you can do is, after the step 1 over here, you can directly do this interval as step 2. but now I'll write it as step 3 because I'm doing it now. So what does this mean? What intervals? So we know this is all real numbers, right? So we cannot have anything less than 0. So this dimension x must be greater than or equal to 0. This 6 minus 2x also must be greater than or equal to 0, and 10 minus 2x also must be greater than or equal to 0. This is basically common sense because we know x value must be a positive number. It's a real object. It must be more than 0. So this is what we are saying. So fine, x must be greater than 0 is the lower limit. Now let's solve this one. This is already done. What about this one when we solve? It'll be this one. Okay, I'll be solving it here. 6, I will take 2x to the other side, will be greater than or equal to positive 2x. Let me divide both the sides by 2. It will be 3 is greater than or equal to x. And now I'll write x first. It will be less than or equal to 3. 3 is greater, so the greater symbol must point at 3. So x is less than or equal to 3. What about this? So I will write this over here. 10 is greater than or equal to 2x. I'll swap this entirely first itself. 2x will be less than or equal to 10. Okay, because 2x is less, right? I bring it over here and 10 to the other side. And now divide both the sides by 2. You will have 2 is less than or equal to 5. So here we have got two conditions. One is x must be greater than 0. That's fine. It's open intervals, sorry, closed intervals, 0. But what about the other two sides over here, 5 and 3? What about these? You need to take the lower value. Why? Because if you take less than equal to 5, you can consider 5, 4, 3, 2, 1. But what if you consider 4? Let's put over here x as 4. What happens? It'll be 6 minus 2 times 4, which will give you 6 minus 8 minus 2. This dimension is minus 2, which is wrong. So you cannot consider this. Though it will satisfy this line, this dimension, it won't satisfy all. So this one just greater than or equal to 0. But over here, we have less than or equal to 3. So our upper limit will be 3. So this is 0 to 3. Now we have this as the limits. So we can eliminate this critical number 4.12. It's not within this range. So a critical number will be 1.21. And also the end points over here of the limit, the closed interval, will always be included as critical numbers. So now we will see this, the number line method. We will start with 0, 1.21 and 3 and take some test values. Here I will take a test value of -1. Here I'll take it as 1. Here 1.5 and over here I'll take it as 4 or 5. I'll take. Now substitute these in derived equation. We have done this, right, just a while ago. Same thing. Now you substitute over here and see how it is moving. Okay, let me use I'll just use the calculator over here. I'll tell you an easy method when there are many critical numbers, right, many test values, how you can do this. So in your calculator, type this equation as it is. Say 60 minus 64 alpha x plus 12 alpha x squared. Write that as it is. Now I've written y over here, sorry for that. It is alpha x. Now what you do is just calc at this value -1. What is the answer? Positive. Here it's positive. Now again calc at 1. Again I got positive. So both are positive. What about this? Calc at 1.5? It is negative. So I will just write over here. We got positive, positive. This was negative. Positive, positive, negative. And let's do the last one. Calc at 5, or you can even do 4. It's again positive. So here it is again positive. Now what do you understand from this? Here you understand it's increasing. This is the maximum. See, this one is maximum and this 3 is minimum. Sorry, not max, minimum. Minimum over here. So 1.21 was a critical number. If the x value is equal to 1.21, you will maximize the volume. This is what? Derivative of volume. So volume will be maximized when x is 1.21. The minimum will be at 3. So what do we need to do? Maximize the volume. So take the dimension of x as 1.21, and then you will be able to maximize the volume. That's the answer. So from this number line, you can consider it. So you need to do the test because it's a very rare situation, but generally it doesn't happen. But these endpoints also can be a maximum point. So better do the number line and check it for sure. So that's the answer. We got how much? 1.21. That is basically this. Let's just check in the calculator. What is this value? I have substituted this entire exact value over here. That is 1.21. That's what we also got. Now, sometimes your options will be like this, and you got decimal. Don't worry, just solve these options, all the four options, and check which is the correct answer. We had got 1.21. Yes, this is the thing. So x should be max. X should be 1.21 to be maximum. That's how we do it. Now, this is again the same problem. We just now solved it, right? It's just that over here it's 12 inches by 16 inches, no top. Please try to solve it by yourselves. Here also you have to maximize the volume, and then you can just do what we just now did. Solve it, do the number line, and find the critical exact value where you get maximum. Here is the worked out solution as well. And this is the last problem here. A box with no top is built by taking a 6 by 6 piece of cardboard, okay, cutting x inches squares out of each corner and folding up the sides. It's the same thing what we did. Okay, the 4x inches squares are then taped together to form a second box with no top or bottom. Okay, this is interesting. Find the value of x that maximizes the sum of the volumes of the box. Okay. See, you need to do the same method, but over here there is an extra part as well. We need to add this x also volume. And then we need to repeat it again for 4-inch by 6-inch piece of cardboard. Okay. So first we need to do this. Okay, I will do one of this, okay, and this is the same thing, repeat. If you have understood the previous problems thoroughly, you can attempt this by yourselves. It is just that there are two volumes. But anyways, now I'll solve this up. Here first let's write the volume formula. V is length, width and height. The same concept. Now I'm not going to draw I'll just draw it. Here we know it'll be taken out and be folded. It's 6 and 6. Minus 2x, and the height will be x. You need to substitute it over here. Length is 6 minus 2x, and the width is also 6 minus 2x, and over here multiply by the height x. Now first thing, this is the first box, okay, this box. Now I'll consider this as V1. It's much better. No, this is volume in general. Now what I'm writing over here is basically V1, okay, for this box. Now let me multiply this. 6 times 6 is 36 minus 12x plus 4x squared times x. And then what happens is it'll be 36x. This will be minus 12 will be minus 24 x, and multiply this x will be x squared plus 4x squared. And what next? Something I've missed out. Okay, over here there'll be x into x is x cube. Okay, so this is basically the volume of the first box. Now what about the second volume, the second box? It is all dimensions of x, right? The top and bottom is okay, not there, fine. It's x, x, x. So what is it? It's a square. Now how do you find the volume of a square? It's just x cubed. Why? Because it's the same dimension, x times, okay, so now thickness, height, everything is same. So basically the volume is x cubed. Here they have told, find the value that maximizes sum of volumes. So what we do is V equals V1 plus V2. So what happens here? I'll rearrange this right properly. 4x cube is there first, minus 24x squared plus 36x plus x cube. 4 plus 1 will be 5x cube minus 24x squared plus 36x. That's the thing. Now we need to derive this. That's V of x only. Now derivation v dash of x will be equal to, derive this, 3 comes down, it will be 15x squared minus 24 into 2 is 48x plus 36. Now make this equal to 0 and put it in the calculator and solve it up. Before that, now here we need to find the interval, right? But remember, from one box, we are doing one more box. So obviously the first one will be greater than 0. Here it is open intervals. Why? Because you can't just consider one dimension. Let's see the maximum value over here. It'll be 6 minus 2x. You can't write greater than equal to 0. I'll tell you in a minute. Let's solve this. It'll be 6 is greater than 2x. It'll be 3 is greater than x, or x is less than 3. So the limits are 0 to 3. But it's closed intervals. Why? Because you have included the volume of another thing as well, right? So what basically you can say is the critical numbers will matter a lot. This just must be greater than 0. It's just positive numbers over here. So even if you leave this, even if you remove this, it's fine. Why? Because all you need is positive numbers in this case. Okay, it should just be greater than 0. Now restricting, yes, obviously we can restrict it less than 3 because it can never be more than 3. No matter what, these critical numbers must be less than 3. But we can't consider this endpoints also as the volume. We can't consider the endpoints. Why? Because if you consider the endpoints, it doesn't make sense. This can't be as long as the endpoint. Okay, if you practically think of it. So only because we are adding the two volumes over here, we are not going to include, it's not a closed interval, it'll be open interval. And this is just for understanding. It's mainly x is greater than 0. And it should be any number less than 3. So now we need our calculators to solve this critical numbers. I've substituted these values here. It is 15 minus 48 and 36. The critical numbers are 2 and 6 by 5 is about 1.2. So let me write the critical numbers over here. X is equal to 1.2 and 2. Now here, since we have two critical numbers within the range, we need to consider both. Now you can do the number line, but what if the critical numbers both are increasing? So what we can do is, because see, it's a polynomial. Anyways, so what we can do over here is the easier method is just directly putting this equation into this given volume equation and finding which is giving you maximum value. Now we see I was doing the first number line, right? The first derivative test by number line. Try to stick to that itself because we have done it many times, so stick to that. But in this case, because we have two critical numbers, we need to substitute this in the volume equation, find which is giving you a greater volume, and that would be the answer. Let us do that now. All I did is I put this volume, sum of the two volumes, right? This equation, and now I will calculate it at say 1.2. What is the answer here? At 1.2, I'm getting 7.28, but check the volume 2 also. Calculate at 2, I'm getting 16. So which is the maximum volume? Because we are supposed to find the maximum volume, right? It is 1.2. So when x is 1.2, you will get maximum volume. So you can see over here, all that we did, maximizing at 1.2. Now for the next question B, you have to do the same thing, but just that we had done this, right? Over here, can you see this? Here it will be 1 will be the same, 6 minus 2x. 1 more will be 4 minus 2x. And what will be this end limit? Here we would have 4 minus 2x must be greater than 0. It's again open limit itself, and it will be 4 is greater than 2x, and 2 will be greater than x. So x must be less than 2. The limits will be 0, 2. That's the difference. And over here it will be 4. That would be the change, and then everything is same. Obviously the critical numbers will also change because the values will be different. You can see over here it's written out over here. So this would be the answer. It will be 0.911. So that is how we basically solve this real world problems on optimization. That's all the problems. I would highly recommend you to solve each of the problems by yourselves and practice. Question 17 is problems on related rates. These are all real world problems. Let's do the first one. I'll do this in very detail. I'll write the given, everything in detail. For the next one, you can try it by yourselves and I will just go through the important parts. Now, first thing, read the question, understand what they have asked you. Here they have told oil spills out of tanker at the rate of 120 gallon per minute. The oil spreads in a circle with the thickness of 1/4 inches. Now remember here, whenever you have say 5 feet, it will be given like this. 11 inches will be 2 dashes. Okay, 1 dash is feet, double dash is inches. A height of 5 feet 11 inches can be denoted like this. Now, given that 1 feet cube equals 7.5 gallons, determine the rate at which radius of the spill increases when the radius reaches 100 feet and 200 feet. Explain why the rate decreases as the radius increases. Now, this one is very simple. I'll just explain you why this does. Now, imagine you have a jar of oil and you pour it in the ground. So this is you pour it on a table or a plate, a huge plate. Now we pour it in. Initially, what happens? As soon as you put, imagine there's a constant rate of volume. See, the volume is a constant rate. You pour it at the same rate, like you're not pouring once more or less. It's the same rate. What happens? It increases, increases. Initially, it increases quickly to a bigger circle, right? It becomes big. But as it goes bigger, the rate of change of radius, in the sense the circle becomes bigger very slowly. Why? Because there is too much space already, too much area in this to cover. So though the volume is at constant rate, the circle becomes slowly bigger. But initially when it was small, it becomes quicker. So what happens is, whenever the radius is smaller, if the radius is smaller only so much, the rate would be high, the increasing rate would be high. Whereas as it increases, as the radius increases, the rate reduces. That is how it works generally, everywhere. So I'm sure if you see the answers, these both answers, the rate over here, r dash, is what we need to solve, will be smaller, sorry, will be bigger for 10 100 feet than 200 feet. Just, you can do this experiment. Just pour some water in a plate, a huge plate, and you can see the same thing, but pour it in a uniform volume. Now coming back to the question, I hope this is clear, why I just now explained. Now, how do we solve the problem here? First thing, I will tell you the conversions. They have told us gallons and inches. We need to get everything in terms of feet or feet cube. Okay, so how do we do this? So the gallon conversion, now I will write it out over here. 1 feet cube is equal to is 7.5 gallons, right? So how many feet cubes, we don't know this, will be 120 gallons. Just cross multiply it, you will get the answer. Take x to the other side and all the things over here. 1 times 120 and divided by 7.5. This would be the answer for gallons. Now, what about inches and feet? 1 feet is 12 inches. So now then, how much feet is 1/4 inch? Take this to the other side. It'll be 1/4 divided by, so this will go down. So I'll just write 1 by 12. Okay, this will be equal to x in terms of feet. It'll be 1 by 48. I hope this is clear. This is in terms of feet. We have 1 by 48 feet thickness and 120 by 7.5 feet cube of volume, rate of volume. This is the conversions. You need to know this every time. From gallon to feet cube, just divide any of this value given by 7.5, you'll get the answer. Now for this, what you need to do is, you have to just whatever you get, divided by 12 and you will get the answer. So this is one way to remember. Now I'll clear that out. Let me write the given things over here. Given, we have rate of volume. I'm not going to write it in words. I'll just write it in terms of the symbol V dash, right? Is 120 by 7.5 feet cube. That is one thing. Then the thickness. Thickness, I will write it as D, depth. That is 1 by 48 feet. And what else do we have? For the option A, radius R is given as 100 feet. And option B, R, question B, sorry, R is 200 feet. And what do we need to find to solve or to find? It is rate of radius. Now, these are all with respect to time, okay? With respect to time. They're changing with respect to time. But I'm not going to write bracket T all the time. We know in related rates, we always have to mention this. I'll just write over here, all the rates are related with respect to time. With respect to time T. Okay, this is the thing. Now let us start solving. Which is the formula you can use to solve over here? We know volume is rate of volume is there, so we need to have volume and derive volume to get rate, right? So let's use volume formula. Volume is what? Area times the thickness. So thickness or the depth. Okay, I'm just writing thickness here because they have total thickness. What is area? Now, which shape does it does the oil spread? It spreads circular. So area would be pi r squared and the thickness is d depth, and that's the volume. Now we know the depth is how much? 1 by 48. So I'll just write this 1 by 48 here instead of d. I'll write pi by 48. Then we have r square and volume. Now this will be with respect to t. Here this square will be outside because this is also with respect to t. Only for this I'm going to write it. Now any more, please remember this is all with respect to t. So let us derive now on both the sides. Volume, what happens here? It is all implicit derivation. Now here, since it's only volume, just derive, it would have been 1 if it was with respect to volume, but we are deriving with respect to time. So we just write v dash of t, then that equal to pi by 48. Now this 2 comes down, 2 times radius with respect to times derivative of that. We always add the dash, right, in implicit differentiation. That is what we are doing. Now here you can simplify. V dash would be 2 cancels over here one time and 24. So it's pi by 24 r into r dash. Now what do we need to solve for? We need to solve for the rate of change of radius, r dash. Let's leave r dash here. Let's take everything else to the other side. It will be 24 times v dash by pi r. This is the rate of radius. Now we have to just substitute what all the given values. So for the first a, we will substitute over here r dash is equal to, it will be 24. What is the rate of volume? It's given by 120 by, I'll just write by over here, 7.5. Now what is the other things remaining? Now 24 v dash is this, pi into what is radius r? R is 100. So this is it. Now r dash would be, just put in the calculator, you'll get the answer. But before that, I'll just write the second one also. R dash over here, this is for 100, this is for 200. What's going to happen? It's going to be the same thing, 24 into 120 by pi, but the radius here will be 200 instead of 100. So that is it. Let's solve r dash as well. Now let's take our calculators and solve. I have just substituted all the values over here. 24 times 120 divided by pi times 100 times 7.5, and the answer is 1.22. So your r dash value is 1.22 feet per minute. So for each minute, the radius changes by 1.22 feet. Now, what about the next one? For 200 radius, just change this to 200 and you can see there is a decrease. We initially told, we saw that doesn't matter what, as the radius increases, the rate reduces. And yes, we can see here the rate is reducing, and that is 61 feet per minute, 0.61 feet per minute. This is how you can easily solve this problem. We got the A, B for different radius. You might get only one in the exam. But remember, explain why the rate decreases as radius increases. Because as the radius increases, the surface area is more and more volume is taken to consume. So that's why as the radius increases, the rate reduces. They're inversely proportional to each other. Even in the formula, okay, now I just told you the practical application. Now just look over here. Rate is over here. How is it related to radius? It is inversely proportional, right? So you can also like leave these are all constants, right? So let's take it as r dash equals k divided by r. So what is basically this? R dash is inversely proportional to the radius. The rate of radius is inversely proportional. So when one goes up, the other one must go down. Okay. So that is the actual technical explanation. I just realized that. Anyways. So this is how we can solve it up. You can check the answers. Yes, we got same one, 0.611 and 1.22. Please try out this problem by yourselves. It's literally the same thing, but just the gallons over here is 90 gallons and the thickness is changed. Please try it by yourselves over here, then check the answer. Over here it's given. Okay, over here they just ask the rate of change of radius with respect to time. It's similar. Same formula, just substitution and then solving it up. Now, oil spills out of a tank at the rate g gallons per minute. The oil spreads in a circle with a thickness of 1/4 inches, given the radius of the spill is increasing at a rate of zero point 0.6 feet per minute. When the radius equals 100 feet, determine the value of G. We have to determine the value of the G value, that is the volume, basically, rate of volume, V dash. Now, then, if the thickness of the oil is doubled, how does the rate increase of the radius change? Okay, this is later. First, let's do the first one, and then we will analyze it. So, what do you do over here? Let's just like what we have done. I'll do it quickly. You can write how we wrote in the first one, the given. In the first problem, we wrote given, to find, formula, everything in detail, right? Please do write that, and the statement also. All the rates are related with time. Not going to write it again, but please do remember. Now I'll just write volume. What is volume? It's pi r square times d. Why? Because it is in circular over here. They have given the thickness and they have told it is in terms of circle. So it is area pi r square and d. Now here, what is this in terms of, what is the inches in terms of feet? 1 by 4 inches, right? We just now did it. It'll be 1 by 48. Why? Because you just divide this by 12. When you divide it, it will be 4 times 12, 1 by 48. And volume we do not know, it is G. But leave that, sorry, we don't know volume, we know rate of volume is G. So leave volume as it is. This is not, this is known, this is not known. So write it as V is equal to pi r square into 1 by 48. Now, derive it out. V dash will be equal to pi by 48 times 2 into r dash. This is what we did. Now, what is G? G is the volume, right? Now, over here, let's write divided by G divided by 7.5. Why? Because the radius over here is in terms of feet. Now, what did we do with the thickness? We converted into feet. So this one, G is in terms of gallons, just divide by 7.5, it'll be in terms of feet cube. Okay? So V dash is G divided by 7.5. That is equal to pi by 48 times 2 times, what is the R over here? Now, rate R dash is given. R dash, this is R dash. And radius is 100. So 100 times 0.6. Now you can solve this up. You can take everything to the other side and solve it up. Let's use our calculators and solve this. Just substitute all the values. It's pi by 48 times 2 times 100 times 0.6. And don't forget that 7.5 from the other side. And the answer is 58.9. This is in terms of feet cube per minute. So all you need to write is G in terms of feet cube we are finding now. Determine the value of G. G is equal to 58.9 feet cube per minute. That's the answer. That's the option, question A. And what about if the thickness of the oil is doubled? Okay, if the thickness is more increased, how does the rate of increase of the radius change? Okay, now what happens is, I think so it'll be halved. C over here. Yeah, it'll be halved because all constants. Now look at this equation here. Volume, let's keep only radius over here. This goes to the other side, thickness, and pi to the other side. And what happens here? It's r squared. Now these both are constants, right? These both will be constants. Now here, when you derive it, you'll get 2r into r dash. So rate is inversely proportional to the thickness. Inversely, it's opposite. So if the thickness is increasing, if the thickness is increasing, I'm telling, if it increasing, then the rate of increase of radius will decrease as thickness. And even you can think of it practically. Now if you have, say, a container and you put oil, so if the or any liquid, say for example, if you put water, it easily spreads out. Why? Because its thickness is very low. It's not viscous. It's very very thin, right? It easily flows everywhere. But now if you put honey, for example, which is viscous, the whose sort of thickness is there. When you pour it, there'll be some thickness. So as thickness is high, the rate of change of radius reduces because it takes time to flow aside, right? So that is one more thing. Now if you see over here, since all are constants, now if you're doubling this, what happens basically? D is doubled. That means you half the rate, because even over here there's a constant, go to the other side. R will be reduced by, it'll be halved. As you increase, two times, this will be halved. Let's just check the answer. So this is the answers, and the other one is just writing. You can see over here the change of radius is halved for doubling it. Otherwise, if it is thickness is increasing, you can just tell the change of radius is decreasing. That's the same answer which we got, I believe. Yes, it's feet cube per minute, 58.9. Now there is another problem. Okay, this is also interesting. I'll quickly do this one. Assume that the infected area of an injury is circular. If the radius of an infected area is 3 mm and growing at a rate of 1 mm per hour, and what rate is the infected area increasing? That's the part A. And find the rate of increase of the infected area when the radius reaches 6 mm. Explain in common sense term why is this rate larger than the part of A. Okay. So whenever they have asked you compare this, that, it's just direct, see how is it related. That is it. Now first we need to realize there's no volume here. It's not like the previous oil pouring out. It's just an injury on skin. The surface area, it's circular. It's just a surface area only. So write the formula. You need to write the given finding and everything. I'll just write the formula of area, that is pi r squared. Now I have been told over here, assume the infected area, if the radius is given and it's growing, what does that mean? That is, rate of change of radius is given over here as 1 mm per hour, right? So first we need to find, what do we have to find? What is the infected area increase, the rate of area? So we derive this A dash equals pi into 2r into r dash. A dash is what we need to solve. It's very simple, in fact, because you just have pi into 2 into what is the radius? It's 3 times 1, because over here it's 1. Solve it up, it'll be 6 pi. That's it, 6 pi millimeters, because it's all in millimeter area is square per hour. It's not in per minute, it's per hour over here. That's it. That is the part A. Now the next one, what did they tell? They have told, if this is radius is 6, r value is given as 6. Over here r was 3, r is equal to 6. Let's solve it. Same thing, A dash is pi into 2r into r dash, right? Let's substitute. It'll be pi times 2 times 6 times 1, and this will be 12 pi mm square per hour. Very simple. Now here, explain in common sense term why rate is larger than that of part A. Why is it? Just think for a minute. It is very simple. You can directly tell over here. It's directly related, right? How is area and the rate of radius or the radius related? Directly related. So as one increases, obviously the other one increases. Over here, the radius was increased, so obviously the rate of area also will increase. Even you can think it practically, you will understand the same thing. So that is the answers. It is 6 pi and 12 pi mm square. And over here, they have given more details. It's the same thing. But yeah, you can just say even it's directly related. Any one reason, but it should be a valid reason. That's it. Or as I was showing you with the example, you can even write the example. You can see they have written so much details. You can give an example and, write it out. Now we have over here about a raindrop again. The formula is different, so I'll solve this one as well. You can pause the video, try solving it by yourselves, and then continue watching the explanation. Here we have been told that a raindrop evaporates in such a way that it maintains a spherical shape. Given that the volume of a sphere of radius r is volume v is equal to 4 by 3 pi r cube, and its surface area is also given, that is 4 pi r square. If the radius changes in time, show that v dash equals, that is the rate of volume is equal to area times rate of radius. If the rate of evaporation v dash is proportional to the surface area, show that the radius changes at a constant rate. Okay, there are too many things. I read it all out, but it's better you split it out in part by part. So first thing, I realized that we need to show from this to this. We need to prove that this is equal to this, provided area formula is given. So I will just start deriving this because I need v dash. So I have to derive this, otherwise there's no way I'll get it, right? So v equals 4 by 3 pi r cube. For your exam, please write the given to find and everything, and also with respect to time t also you need to write. And here I'm just writing it directly. So v dash is equal to, derived it. This remains same, 4 by 3 pi remains same. What happens over here? It'll be 3 times r square times r dash. Now simplify this. V dash is equal to 4 pi r square times r dash. Now let's see what is the area. Can you see this area formula is given? Area is equal to 4 pi r square. So now this much is A basically. So V dash is equal to A times r dash, and that is what we have been told to solve, right? Yes, see, we have shown that V dash is equal to A times r dash. Now, if the rate of evaporation V dash is proportional to the surface area, what this means is V dash, it's with respect to time, all is proportional to what? Area with respect to time. Show that the surface area changes at a constant rate. Fine. Now, here, let's leave that area is like this only. Let's substitute what is V dash. What is V dash? We know it is area times rate of radius, right? But before substituting it, I forgot to remove the proportionality. How do we remove this proportionality? When we remove proportionality, I'm sure you have seen this in physics. When you make it equal, you put a constant and then multiply area times area with respect to t. That's it. So this is in terms of equation. So they have told it's proportional to surface area. Volume is proportional to surface area. To remove the equal to, you need to multiply a constant over here at the right side. And now I will substitute what is V dash. V dash of t is A times R dash of t. This is also with respect to time. That is equal to K into A. So area cancels. If you divide both the sides by area, that's gone. What is rate of change of radius? It's a constant of proportionality, right? K, any constant. So now this is how we have proven here, show that radius change is a constant rate. See over here we have got r dash is equal to k. So this is how we can easily prove it up. Now if you're thinking what happened here, see this is proportional. Why? Because they have mentioned V dash is proportional to surface area A. And then to remove the proportionality, you have to multiply it with constant of proportion at the right side. And over here we get V dash is equal to K times A. But we know the rate of volume is given as area times the rate of radius. So area and area on the two sides cancel. You will have rate of radius change equals K, that is a constant value. I hope that much is clear. And we will, yeah, we it's clearly explain the same thing. Now I have cancelled this a and a. I've just left r dash, but you can see over here that I've left a and a. It's the same thing. Just follow what I've written. This is more better. Okay, that's it. Now we go to the sixth one. Again, another easy problem. I highly request you all to solve this by yourselves. This is very simple. I'll just solve it over here because there's nothing much here. The forest fire is spreading in a circle with radius changing at the rate of 5 feet per minute. R dash is given, and the radius r is given. We need to find the rate of area of the burning region increasing. Area is, this is circular, pi r square. Just derive both the sides. It will be a dash is equal to pi into 2 times r into r dash. Now substitute all that you know. Pi times 2 times what is r? R is 5. Multiply this, and r dash, sorry, r is 200. R dash is 5, and this is 200 radius. Multiply here, it'll be 5 times 2 is 10, 10 times it'll be 2000, 2000 pi. 2000 pi, what is the units? It's in terms of feet, so it'll be feet square for area, rate of area, feet square per minute. So what is happening? Every minute it is increasing by 2000 pi feet square. The area is increasing. So this is how we can solve it, and you can see it's the same thing over here. It's a very simple one. Okay, I hope you remember we had done in the related rates this sort of problems. Now we will do this problem here. This particular figure is from the example 2 because I mentioned it clearly. The same situation is even used over here. So a 10 feet ladder leans against the side of a building, as an example 8.2. If the bottom of the ladder is pulled away from the wall at the rate of 3 feet per second, and the ladder remains in contact with the wall. It's in contact. That means though it's moving, it's still touching the wall. And we need to find the rate at which the top of the ladder is dropping when the bottom is 6 feet away from the wall. That means when x 6 feet away, in the sense this x is 6 feet. When it's 6 feet, what is the rate of this change? Then find the rate at which the angle between the ladder and the horizontal, this angle theta, is changing when the bottom of the ladder is 6 feet. Okay, at 6 feet, what is this angle and what is this rate coming down? Two things to be solved. Now the figure is given here. I will just write few things. The rate over here will be x dash, dx by dt. You can write it as dx by dt as well, and over here it is dy by dt, all with respect to time, or you can write it as y dash x dash. Now what is this? X is given as 6. Now from here you can find y, isn't it, from Pythagoras theorem? Let's first find that. Y is equal to what? Square root of the hypotenuse square minus 6 square. If you're thinking why, because we know hypotenuse means opposite to 90 degree. 10 squared, square of that would be sum of these two squares, x squared plus y squared. We know the value of x squared, that is 6 squared plus y squared. So take this 6 squared to the other side, it becomes minus, and take square root. This is square, right? Take square root, you'll get this. It'll be 100 minus 36. So 100 minus 36 is 64. So here you will have 8. Square root of 64 is 8 feet. Now we found y as well. Y is 8 and 10. At the situation, x is 6, the y value is 8. Now what do we need? We need to find this y dash. How can we connect all this? Same this Pythagoras theorem, isn't it? This formula itself. I'll write it out over here again. 10 square is equal to x square plus y square. Now derive on both the sides. Over here it's a constant, becomes 0. It'll be 2x into x dash, because we're doing with respect to time, plus 2y into y dash. What else? Now over here, we need to find y dash. Leave y, this term over here, take everything else to the other side. I'll write this first. 2y into y dash equals, this goes to the other side, minus 2x into x dash. Now only y dash is what we need. So 2 and 2 cancels. You will have minus x times x dash divided by y. This is the term. Now what next? Substitute the values which you just found out over here. X value is 6 given. X dash is also given. What is it over here? 3, right? 3 feet per second is x dash. Multiply it with 3 divided by, what is the y value? 8. So just put 8. Now simplify this. It's 3 times 4 times. It's negative 9 by 4 feet per second. This is the answer. Now we can put it in the calculator. It will be 1 times 2 times 8 and 1/4. 8 1/4 or 2.25. So negative 2.25 feet per second over here. That is the rate at which it's coming down. See, minus means it's going downwards, right? That's why, okay? So it's the top of the ladder is declining or coming down by a rate of negative 2.2 feet per second. Then what is the angle? They have also mentioned the angle, this angle theta. You can use any trigonometric function that relates these three, which theta must be there. That's it. Now I will just take sine. The reason me taking sine is because when we derive sine theta, what happens? It's positive cos, right? If I take cos, it's fine. Even tan is fine. Oh no, don't take tan because secant is very high. I mean, you can. It's reciprocal secant and all. Take sine or cos. Cos would be negative, so I'll just take sine to avoid the negative sign. Sine theta is equal to what? Opposite by hypotenuse, isn't it? So what is the opposite side? Opposite to theta is y, by hypotenuse is 10, and sine theta is sine theta itself. Now, if you're thinking, why am I not substituting the value of y as a constant value? I know it's 8, isn't it? Why am I not substituting it? If you substitute it, then you have nothing to solve with. It'll be right side equal to 0. You don't have. You need to keep something. Now we will derive on both the sides. So now the derivation of sine will be positive cos theta. That is equal to, over here it will be y dash by 10. That's it. Now what is cos theta? Cos theta is adjacent by hypotenuse. Adjacent x divided by 10. What is x value? It's 6 by 10. This is 6 by 10 equals, what is y dash? Y dash is over here, sorry, theta dash is the cos theta. Oh, I forgot to tell you, theta into theta dash. Don't forget this. That is theta dash. Why are we doing this? To find the rate of the theta, right? Rate of angle. So sine theta would be cos theta into implicit derivation. It's theta dash. Here cos theta is 6 by 10, adjacent by hypotenuse. And what is y dash value? We just now found it, right? It is negative 2.24, or you can just write it as negative 9 by 4 into 10. Now this goes to the other side. So theta dash will be minus 9 by 4 into 10. And this 10 goes up and 6 comes down. So solve it up. Here you will have 3 times and 2 times. It is 3 by 4 times 2 is 8. It's minus, I'll write it over here, theta dash would be minus 3 by 8. And this is in terms of radians per second. I'll write the answer properly here. The B answer would be minus 3 by 8 radians per second. That's the correct answer. You can put in the calculator and solve it for the decimal form as well. So you can see that's how we do this problem. The first part we got was negative 2.25, yes, and the next one was negative 3 by 8 radian per second. We moved to question 8, which is another important question. I did this in my class, and one of my student, Abdullah Hussain, he solved this properly. I mean, the derivation is tricky, with the tan inverse. So he did it all correct. So I was really impressed by him. He did it on the board. So I remember this. Now we will solve this out over here. The height of this, there are two buildings they have given in the figure here. The height of the first building is 20 feet and another one is 40 feet respectively. And they are 60 feet apart. This dash indicates feet. If it's double dash, it's inches. Suppose that the intensity of a light at a point between the buildings is proportional to the angle in this figure. Now imagine the two intensities of this light. This is the angle formed. Now, if a person is moving from right to left, so from here, this person is moving from right to left at the rate 4 feet per second. Now, this is important. What is this rate? This is in terms of time. Now, you can write this as x dash. I'll write it in terms of dx by dt because this is with respect to time, right? Feet per second. What does it mean? Feet is distance x, right to left, horizontal distance. Time is because it's per second. At the what rate is theta changing from the person when the person is exactly halfway between the two buildings? Now, when the person is exactly halfway, that is 30 feet, what is this? What is the rate of change? What is the rate of change of theta? dt, d theta by dt. Now, this is what we need to solve. But we have no things over here. Everything is with respect to x, right? This is distance, distance. We don't have much things to solve directly dt by d theta by dt. So I will just tell you a formula quickly, not going in too much depth. Now, whenever you have this derivative over here, d theta by dt, that is the rate of change of angle with respect to time, by relating with two different rates. That is d theta, I can split it out, and over here dt I can write. I should have same things over here. In the sense, whatever I write over here, now if I write something, say y, it must be y over here. But now since I know dx by dt, I'll write dx. Why? What happens? This cancels out and you're going to get the same thing. But these are two different quantities that are related. So this is the simple formula. Now rate of change, what they're asking, what is the rate of change of angle, right? Theta with respect to time. That is d theta by dx, that is dx by dt. Now, why we did this is because we can easily find d theta by dx because we have plenty of information to solve this. But dx by dt is already given. That is given 4, right? We can easily solve it up. We need to find this and then multiply by 4 and then we will get this a, exactly what they are solving for, what they're asking us. So this is the concept. Now, before that, how can we relate theta now? This is a big problem because there is nothing much you can do because it's not an enclosed figure here. It's not an enclosed polygon. We can't do anything over here like 90 degrees or anything. We have to take these two theta angles. So I will write this as theta A and this as theta B. How can we relate it? We can relate by one simple equation. The total, it's a semicircle, right? 180 is equal to theta A plus theta B. But what is theta and theta B? We need to find theta dash, yes. But theta A, I'll write it out over here, is can be related by what? Opposite by adjacent. That is tan theta. Why? Because this person is walking, isn't it? Now imagine whatever is walking, like this point, let's consider this is x. So what is distance covered will be 60 minus x because the total is given. So it's not about the person when he is at 30, it will be 30, 30 only both. But here, if we consider this distance, left side to be x and the right side will be x minus 60 minus x because this is the point in consideration. Over here, the theta is happening, right? So that means over here, theta A can be written as tan theta A, tan theta A is equal to opposite, that is 20 divided by x. Or we can also write this theta A equals tan inverse of 20 by x. This is the value. Now what about the other thing? Tan theta B is equal to what? Opposite, that is 40 by 60 minus x. This is equivalent to theta B, that is tan inverse of that thing over here. Tan inverse of 40 by 60 minus x, close the bracket. Now all you need to do is solve these both. So substitute them over here. So we know 180 is equal to theta A. What is theta A? It's tan inverse of 20 by x plus theta plus tan inverse of 40 by 60 minus x. So this is all the substitutions. Now derive both the sides. When you derive the left side, obviously it'll be 0, but what about the right side? Here, this is tan inverse formula. What is the derivation d by dx of tan inverse x? That is equal to 1 by 1 plus x squared, isn't it? So here it's going to be 1 by 1 plus x squared, that is 20 this, the whole squared. Multiplied with the this again, you have to do chain rule. What is the derivative of 1 by x? I'm not going to take x to the power minus 1 and solve. I'll directly write the formula. 1 by x is minus 1 by x squared. So this is the derivation of the first one. What is theta? Now everything is with respect to x over here. So theta is derived as theta dash with respect to x. Or you can write it as d theta by dx. It's fine. Plus, what about this? It's the same thing which we just now did. 1 by 1 plus 40 by 60 minus x, the whole square. That is x, tan inverse x, right? Multiplied. Now derive this. Now again, when you derive, it will be the power rule itself. You can take this up over here and then solve it up, or I will just write it as, okay, now, my bad. I just realized one mistake I did over here. I ignored the 20. The 20 remains. That is chain rule. This 20 is a constant, right? This entire thing must be solved. Only 1 by x is minus 1 by x squared, but there is 20. That's a constant. Write it as it is. Same thing here. Minus 40 divided by 60 minus x the whole square and times minus 1. Why? Because there's another chain rule. See, this is done. Tan inverse is done. This x, yes, we did it. And then it's minus x, right? The denominator is done. Okay, we have done it. And then minus x derivative would be minus 1. So this remains. Now let's simplify. Try to simplify this. Right? Left side is 0. So what I would do is I can just take this to the other sides. Okay. Now this one minus, see, when you multiply here, it will be minus 20 by x square and this term, right? I'll take it to the other side, it will become plus. This has a minus 1 by x squared. To the other side, it will be 20 divided by x square into 1 plus 20 by x the square. Then again, see, this is like a big bracket, okay? And over here, what happens? Okay, yeah, here this is minus and minus. What's going to happen? It's going to be plus, but then we take it to the other side, it's going to be minus here. So remember, this is going to be plus, but because of we are moving to the other side, it becomes minus. Whereas this one, it was minus. When we moved it, it became plus. It becomes minus. Here in the numerator, we have just 40 divided by, what do we have over here? It is this term. I will just write it out over here. That is 60 minus x the whole square. I've written it first. And this term, you can write that first, it's fine, or you can just write it like this only. You can keep these two terms separately. Now this sign goes, it'll be 40 divided by 60 minus x square multiplied by 1 by this term. It's fine, but I'm just writing it together. It'll be 1 plus 40 by 60 minus x the whole square. Now this is the this is how we solve it out over here. Now this everything is equal to d theta by dx, or theta dash with respect to x. See, that is the thing. Over here, what is the x value? See, only x is the unknown variable, and they have told when the person is what? Walking halfway, isn't it? Now just consider x is equal to half of 60 is 30, and solve it up, you'll get the answer. Let's do it in the calculator. Now I've typed this entire equation with in terms of x itself, that's fine. 20 divided by x squared times 1 plus 20 by x the whole square, then minus, here it's 40 divided by 60 minus x the whole square, bracket 1 plus, again bracket because this must be squared, right? 40 by 60 minus x the whole square, and then close the bracket. Please use the brackets appropriately, otherwise you may not get the correct answer. Now we will press calc and we will just solve it at 30. And you don't need to press plus, directly 30 is enough. The value is minus 1 by 625. And yes, that's the correct answer. Wait, let me just, okay, over here. Let's write it out over here. That is the value of dx by dt. This is minus 1 by 1625. Now, this is not over. This is in terms of radians per feet. Why? Because we did all with respect to distance x, so it's radian per feet. But what do we want? We need d theta by dt, right? D theta by with respect to time. So this negative 1 by 1625 must be multiplied by 4, and now we will get radian per, and this feet and feet cancels, we'll get radian per second over here. Since everything is used in second, it will be radian per second. Now that will be 4 times 1 by 4 minus 4 by 1625. We can just multiply over here by 4. The answer is this. It's 0.00246. Okay, I'll just write it out over here. It'll be 0.00, it's 1 2 3, yeah, 0025. I'll write that is theta dash with respect to time. You can see radian per second. That's how we solve the first part. Now here, find the location at which the angle theta is maximum. This is simple. I'll tell you why. Because over here we need to find x, where is it maximum, right? D theta by dx we found, right? Here all you need to do is, after deriving, see, we derived this with respect to x, this make it 0, this is the critical number, we need to find x critical value, right? The same thing, only this step we have done, right? We derived it, make this derived theta dash as equal to 0. Why? Because I just write it out over here. If you have a function, say f of x is equal to 2x squared minus 3. Now, how to find the critical number, maximum or minimum? Maximum is f dash of x first, that will be 4x, that's it, 4x. And then we make this equal to 0, right? And what do? After making it equal to 0, we equate it. At x is equal to 0, it's the maximum minimum number. This is the critical number, right? Same thing, this is the equation. Theta dash is there. We make theta dash equal to 0 and solve for x. You can, in fact, entirely put this entire thing in the calculator and just solve, shift and solve, you'll get the answer. So this is how we basically solve the part A and B. I've just typed this entire equation again as it is, and over here you can see it's minus the same next part, but equals to, you can see now, is given as 0. So equal to 0. Now you need to press shift and solve and then press equal to. This is the answer. X is equal to 20. So for the question number B, you can see here, the location at which theta angle is maximum is when the x value over here, this value is 20 and other distance must be 40. So that is the actual distance. Now we have considered x to be from the left side. So this must be 20 and the other distance will be 40. Now, if at all you're not getting your answer in the calculator, just clear your calculator. You will definitely get the correct answer. And please use the brackets properly, because I had an issue. I think so I had not put in some of the value properly at the beginning. I was not getting the correct answer. I cleared my calculator and typed it all in properly. And I did get the answer. When I press shift and solve, then equal to, you will get the answer 20. So that is how we basically solve it. It's a lengthy one. So here these are the two, this is the correct answers we got. And then over here x was how much? At 20. So yeah, x is 20 when to be maximum, the theta will be maximum. Now we have another problem. This is also a bit different, so I'll solve this out. A plane is located x is equal to 40 miles horizontally away from an airport. So it's better we draw a figure. So it's 40 miles. Now imagine this is the airport. I'll write a airport, okay, AP. And the airplane is at an altitude of h. So I'll write this height, okay, this height, h, and this is the plane, okay, airplane. Okay, it's going to be a problem if I write airport, airplane, same. I'll just write P over here. This is the A plane, which is 40 horizontal miles away. Horizontally, x is equal to 40. Now, a radar at the airport detects that the distance s of t between the plane and the airport is changing at the rate of minus 240 miles per hour. So this distance from the plane to the airport, okay, from this over here, the rate of change, we don't know the distance, sorry, the rate of change s dash is given as minus 240 miles per hour. Now, if the plane flies towards the airport at constant altitude, the altitude is same, h is 4. What is the speed x dash? Now, this is x. We need to find the rate of speed x dash with respect to time of the airplane. Then repeat with a height of 6 miles. Then the first time over here, h is given as 4, right? For B, h is equal to 6. Option B, A, h is equal to 4. That's the thing. And based on your answer, how important is it to know the actual height of the airplane? Okay. So now first let's solve this out. You need to write the given, what to find and everything. Now, which is the formula that connects all these? It's the Pythagoras theorem, right? But before using the Pythagoras theorem, we know this is 4, this is 40. What is this distance? We can find the distance s by using Pythagoras theorem. It will be hypotenuse square will be equal to sum of these two squares. I'll take square root of 4 squared plus 40 squared. Now, 4 squared is 16. What about 40? It will be 16 and 2 zeros. So it will be 1616 square root. Okay. You can simplify this in the calculator. I'll leave it over here now. And we will use that directly. We will write the formula. I will write s squared will be equal to h squared plus x squared. Now let's derive, but before deriving, do we know the rate of height? No, it's a constant. So we are going to substitute that as 4 squared itself. Now x squared, we know the rate, so we will substitute over here. What about s? We need to find the rate as well. Now let's solve it up. It will be 2 times s into s dash, that is equal to 6. This is 0. Why? Constant derivative will be 0 plus 2 into x dash. Now, this is we need to find x dash. So let me take everything to the other side. 2s into s dash divided by 2 into x is equal to x dash derivative. This cancels out, only remaining with the distance times the rate of change of distance of the plane and airport divided by the distance between them both, the horizontal distance. Now substitute all that we know. What is s? It is square root of 1616. Multiply it with, what is s dash? It's minus 240 given, divided by, what is x? It is 40 miles, right? Now put this in the calculator, you will get the answer. Now, when we put in the calculator, we will get negative 241.2. But we'll take this positive because this x, what is that distance? It's speed. Now, it's the speed along the x dash, rate of change of distance in the sense, speed along the horizontal distance. Now, this one over here is the rate of change of distance between plane and the airport, right? But it is constant vertically, so the speed over here is x dash, and that is what we found out, negative 241, but I'm not going to write negative, it's just 241.2 miles per hour. That is x dash with respect to time. Now then, we have done the part A, that is what they had asked us to do, the speed, that is x dash of t. Repeat this for 6 miles. Now what happens when it's 6 miles? There is simple changes over here. The s value changes. The s value will be 6 squared plus 40 squared. Now 40 is 1600 and 6 squared is 36. So it will be square root of 1636. Now all I need to do is substitute that over here. This changes to 1636. Does anything else change? No. Why? Uh, Only this, yeah, s value. Why? Because the height 6 over here is a constant. When I substitute 6 over here, 6 square, it becomes 0 when I derive. That goes off. So there is no need of changing anything. Only thing that changes is here, and instead of 1616, I'll just put 1636. And the answer is negative 242.68, but we just take the positive sign and I will write it directly over here. B at h is equal to 6. X dash with respect to time will be 242.7 miles per hour. Now, here then, you realize there is no much difference. Now, the last, what they are asked based on your answer, what is more important? Is the height, important or no actual height? You can say it's not so much important. Why? Look here carefully. See, this diagram is not at all to scale. The distance between the horizontal distance between the airport and the plane is 40 miles. Whereas what is the height, the altitude? It's just 4 miles. Now, 4 and then it was 6 miles, right? The difference over here is just 2 miles. It's a very small difference. Now, it's like, two people are very, very far away. Imagine there is two people very far away. Now, here, if the another person stands on a stool which is say 2 feet, does it make any difference? No, not at all, because they are very far and they cannot see them properly. They'll just the height they cannot measure it. It's almost the same. But if that person is very close by, now if he stands on a stool which is 2 feet, yes, it makes a lot of difference. He goes up, right? So this distance is huge and this is very small. So therefore, in this case, that the height doesn't make any difference. Okay, so that's the answer. First one was 241.2, and then next one over here was 242.7. And the difference does not make a large difference in the speed of the plane, because I told you, because the height difference is very, very small compared to the distance between the plane and the airport. And now from this problem, I would highly encourage all of you to click on the link in the description, because all these problems are explained in that video in detail. It was done in your classes. It's the example 8.3. Now this needs to be just recalled, because the next problem over here requires the same thing. Just from this, you can extract few values and solve it up. It's the same figure and everything from the example 8.3. So please watch the video in the description for this information, for this problem information, and then try solving this by yourselves, because it's all related, it's same. Now here the worked out answers are there. Please solve it by yourselves and then check the answers. And even the next one, it's again the same one, and over here please do the same thing. You can do it in different ways, okay, because over here they have used a long method. I have used the Pythagoras theorem itself. Try using Pythagoras theorem, it will be simpler. You can watch the video over there, it's explained in detail in that, and you can refer the sample answers as well. And even this question is clearly explained in the video, so I highly encourage you to watch that video. This again another very simple problem. Everything is given. All you need to do is just derive it, substitute it, and get the answers. So here, this is the worked out solution. Since the same thing is done in the video already, please watch that and then try to solve it by yourself, and then you can refer to the answers. I hope you have found these explanations helpful. Please do share it with your friends who might also benefit from it. I would really appreciate it. And please hit the subscribe button if you have not yet subscribed to my channel. Please do like my videos. If you have any doubts, comment. I will try to get back to your doubts very soon. Question 18 is also problems on related rates, but this time it is about population growth. Now here they have given us the population grows according to the equation P prime of t equals 2 times P of t 1 minus P of t. This is the logistic growth equation, but here it should be R, but the R value is already given to be 2, so we substitute 2 over here. Otherwise, we know the rate of population growth rate is given like this. And find the population for which the growth rate is maximum and interpret it graphically. Now, even if you don't do it graphically, there are plenty other ways to solve it, because you can see we will do the exercise problems. We can do short ways other than graph methods, But now the first thing is to make this equation simpler to understand. We can just write it as function of P. This is 2 times. Now, what I will do is, instead of writing P of t all the time, because I'm taking it as a function of population already, I just write it as P into 1 minus P. This is, you can just multiply it inside, it'll be 2P minus 2P squared. This is the function of P. Now here you need to find the point at which it is growth rate is maximum. This is the growth rate, right? You need to find which point it will become maximum. That's the only thing. Now, which point, how do we find any maximum or minimum points? It's by deriving this and making the derived part equal to 0. So let's derive this. F dash of P equals 2 minus 4P. Now make this equal to 0 and solve for P. This is the point. Now we can just take it to the other side. 4P equals 2. So P is equal to 2 by 4, that is half. At P equals half, at this particular point, it is maximum. Now how do we check it? You can do it graphically and see whether it is, this would be a parabola, isn't it? So this is a parabola. So if it's concaving downwards, if it's opening downwards, then you will have a maximum point, whereas if it's opening upwards, you will have a minimum point. But another way is, you can do the number line method and take test value. This is half, take test value of 0 and say 1 and check it out. If it's increasing, decreasing, then you have a maximum value. The another method, the easier method, is double derivative. The reason doing double derivative is, look at the derived equation. It's just a linear function. It's very easy to derive it. Let's double derive it. When you double derive it, what's going to happen? It is, this becomes 0. It will be minus 4. Now, this is less than 0, right? If it is less than 0, what is it? It is concaving. Double derivative is less than 0. That means it's concaving downwards. Less means downwards. But look at this graph. If it's concaving downwards, it will have a maximum point. Yes. So this is the maximum point. So that is how we can solve it. The most important thing is the critical number is P equals half. So that is the thing we need to solve for. We can see over here, the P equals half over here. We just derived it. That's it. And when you graph it, you can see here, it is, the parabola is opening downwards, isn't it? It's, if you continue to, like, it looks like a downward graph. And now you can see here they have told P, where is P over here? At half. See, this is basically already rate. Now we derived this at this particular point at 0.1. The slope is maximum compared to everything. Slope is maximum. So that is what is explained over here. But anyways, if you understand what I told earlier, that's more than enough. You can easily find this and prove it its maximum. And over here, some more information is given. You can just go through this. Now we will solve this problem. Here the logistic equation is given. P prime of t equals 4p times 5 minus p. So we need to find the population when the population growth rate is maximum. So we need to find the critical number. So let's write it as f of p equals 4p 5 minus p. And now first let's simplify this. Multiply this 4 inside, will be 20 times p minus 4p power 2. This is f of p. Now we need to derive it, find the f prime. It will be 20 minus 8p. This is it. Now you can find the critical number by making this equal to 0. What's the answer? It will be, take this to the other side, it will be p equals 20 divided by 8. The table of 4 goes in this. 5 by 2, that is 2.5. So this is the critical number. Now, how do you check whether it's maximum? So you can do double derivative. F double derivative of P equals, I'm just directly doing it over here, minus 8. So minus 8 is less than 0. So you can say it is concaving downwards. If it concaving downwards, then maximum point only can exist. So maximum point. Therefore, you have just proven it is maximum. And you can see over here also, they have not done the graphs. Yeah, see, it's just that they have done different methods. Yeah, they have just told it's opening downwards. Yes, basically you can easily do the double derivative test and prove it to be maximum. So that is how we can solve this. Please do try this by yourselves. It's just the same problem, same type. All you need to do is multiply this inside and then derive it up and find the critical number. So here you can see when you derive this, it'll be 14 times, now this is already derived, it will be 14 times 14p minus 4p squared, and then when you derive you'll get 14 minus 8p, and then it'll be 7 by 4 because both two tables goes in this. 7 by 4 is the critical number. Just double derive it and find whether it's less than 0. If it's less than 0, then yes, there is only maximum point because it concaves downwards. That is the end of this simple problem. Please do practice all the problems by yourself. Write and solve, it'll be much easier. Question 19 is to compute the area under a curve using summations and limits. A quick reminder, please go to the link in description to the lesson of area where this problem is explained in detail. Over here, I will quickly run through this problem, the example problem, and I will show you another entire different method which you can use to solve the exercise problems, and this example also can be solved in that. But first, let's recall this actual method. What we do is we need to remember a few formulas. Now, area is given by summation of I. It starts from 0 to n. Sorry, not 0, from 1 to n. It starts from 1 to n. And over here, we write f of xi multiplied by delta x. So this is the function of all the height multiplied by the thickness. This is the formula which we have. And now here, delta x is given by b minus a divided by n. The limits are a and b. The lower limit is a, upper limit is b. And n is the number of rectangles we have to divide it into. N is number of rectangles. Now if this area is divided into 10 rectangles, that would be n. But here now they have not mentioned any n, right? So we need to basically consider n as n itself. So delta x will be 1 minus 0 by n. So it's 1 by n. That's it. Now here, what is xi? Xi becomes delta x times I, isn't it? We substitute that x as like this. So now here xi will be 1 by n into I, or we can write it as I divided by n. Now we will substitute back in the formula. Over here, what is the function? This is the function, but let me just write it out over here in the middle. I equals 1 to n. Here, instead of x, what do we write? I by n. So this is being multiplied minus 2 times I by n, the whole squared. And then we can solve it by using the formulas and everything. So we will just quickly run through this problem over here. You can see, I think so they have, they have done the same method. Over here, a little bit different, but that's fine. Here, this is the important part. You can say, oh, now, it's good that I saw over here. Everything is right. What am I missing? I wrote this. I wrote the function entirely. I forgot to multiply this entire thing with delta x. That is 1 by n. So this entire thing is multiplied by 1 by n. Once you get this, you're just solving it. So this is the step 1, step 2, and putting it in the formula is step 3, and now solving it up. Let's just go over here. It's simple solving. So you can see it's 2. Xi is I by n, minus, instead of the x over here becomes I by n, the whole square. Multiply this entirely by I by n. Now over here, remember this n, you can multiply it inside. It will be in both the terms, and then the summation can be multiplied inside. It will be for both the terms, and then you can use the formulas. Remove all the constants out, only I will remain. Okay, this 2, n is a constant, right? N will be a number of intervals, right? I mean number of rectangles. So n is all constants outside, and this can be solved by using the formulas. Now I hope you remember the formula. For summation I, it's very simple, but I squared, it will be n into n plus 1 into 2n plus 1 by 6, where summation of I is n into n plus 1 by 2. And these are the constant values. You can see they are the same constant values remaining. And then you simplify this, 2 cancels, n and 1 n over here cancels. You're remaining with n plus 1 by n. Over here, the same thing, cancel it out. N square remains because n and n cube goes, n square remains. 2 one time, 2 three times, 3 remains, n plus 1, 2n plus 1. And then you can take the common denominator, simplify it, and now you can take the limits. See now n, right? You can take the limit up till infinity. But now if you look over here, 1 minute, let's look over here. This is a formula for an. You can find area for any number of rectangles. Say for example, if you consider n to be 200 rectangles you're subdividing, this is the answer. If you're considering 500, this is the answer. If you're considering infinity, then you can take the limit to infinity and find it to be 1 by third. So this is the actual way. But now I will tell you integral direct method. Now before that, I'll show in calculator what you can do to check this answer. Now this is the written method. It's very simple. After you know the starting part, which I've written over here, right? This is the important part. Then it's direct substitution. Please go through over here. Each step is in detail. Each step is detailed and you just solve it up and then you get the answers, right? Now how do you check this answer? Take out your calculators. The limit n to infinity for an area would be just basically integration. Over here, since it's a definite limit, so it's told 0 to 1, substitute the function 2 alpha x minus x squared, and over here it's from 0 to 1. Press equal to, you get 1/3. That's the actual area. Exact area, that is. So this is the thing, but it's in writing, so you can't use this calculator method. You need to do it in writing. But now the exact area is over here. But now I will show you one method where you can use the integration and solve this one. So now imagine the previous method is fine. It's simple. It'll just be I by n. Everywhere over here, it'll be I by n, okay? It depends on the limits. Over here, it's 2 minus 0. It'll be delta x will be 2 here, okay? 2 by n, sorry, not 1 by n, 2 by n. So it'll be 2i by n. It's just simple variation and then you can easily solve it up. But now, if you want to know how exactly can you do it by integrals, see, this is basically definite integral. I'll do, say, for example, c, because c is having two different 1 to 3 over here, right? This will be x squared plus 1 dx. Now you have to solve this. If you're good at integration, then this is simple. Just integrate it out. See, why I'm telling you this method is they have clearly told this Riemann sums method you have to use, but actually you can solve a problem in any method, but as long as the method is accurate and you use the correct answer, it's fine. You can use it, okay? Before we solve, I'll just show you in the calculator to just check the answer later on, but I'll do it right now. Here it is x squared plus 1, and the limits are from 1 to 3 over here, and the answer is 32 by 3, or it's 10 by 10.6. It's 32 by 3. That's the exact answer. But over here now, whatever we do, they have told exact area. So this is the correct answer only. This method or Riemann sums method to equating to infinity would also give us the n to infinity would also give us the exact area. Now I will solve this up. Integrate this. When you integrate, it will be 1 more power. X squared becomes x3 divided by 3 plus x. Now this is definite integral, so this limits have to be substituted in this. What happens is there's a rule. When applying the limits, the upper limit will be substituted first minus the lower limits. That means instead of x over here, after you integrate over here, see over here will be plus c. You can write this plus c as well, but it'll cancel off in a minute. Upper limit, it'll be x becomes 3 cubed by 3 plus again x becomes 3. Whatever x is there, substitute upper limit first. Plus c minus, see this is the entire thing with 3. Now the lower limit, it'll be 1 cubed divided by 3 plus 1 plus c. Now multiply this minus sign inside. What happens? This is 3 cubed by 3. You can cancel this. It'll be squared. So it'll be 3 squared is 9 plus 3 plus c minus, it'll be 1 by 3. This multiply over here again minus 1 and minus c. So c and c cancels off. Now let's solve it up. 9 plus 3 is 12, and over here we will have 1 minus 1 minus 1 by 3. You can put this entirely in the calculator, you will get the answer. I'll just write it over here. It'll be 9 plus 3 is 12, minus 1 is 11, minus third it'll be 10 point, it'll be 10 2/3. Okay, so now it is basically 10 to 2/3 means 10.677, so 6666 or 67. That is basically 32 by 3 itself. Now I'll show you over here. 10, it is 11 minus 1/3. That will be 10 2/3, or you can see over here it's 32 by, will be 10.677. So that's the correct answer. Over here, generally your answers will be like this, 32 by 3, or like a fraction. I wrote it over here because it's simple to understand. 11 minus 1/3 will be 10 2/3. So that's how we can do the direct substitution and solving as well. Now over here, if you're doing the long method, you can easily do this up, and then you need to take the limit. So this is for any n value. Substitute, solve it, and then do it. Now one more thing over here, if it's any other limit, just this limits changes. See over here, answer will be different. For the first one, the answer is say 4/3. For the second one, answer is again different, 14 by 3. And over here we got 32 by 3. So the answer changes every time. All the other problems are same thing. Whichever method you use, answer will be the same. And I will do one more problem over here, and I'll just use the method which I just now told you. I'll do for the minus 1 to 1 limit. So it'll be integral minus 1, the lower limit will be down, upper limit will be up, 2x squared plus 1 dx. We need to integrate this out. When you integrate it, will be 2x cubed by 3 plus x plus c. Over here we will have 1 minus 1. Now apply the limits. It will be 2 into 1 cubed by 3 plus 1 plus c minus, it will be 2 times minus 1 the whole cube by 3. Again it will be plus minus 1 plus c. Now we can simplify it. It will be 2/3 plus 1 plus c minus, say it will be cube. Over here what happens is minus 1 the whole cube will be negative, and sustains, negative sign will remain. Why? Because you have to multiply negative 3 times. 2 times, say it's minus minus minus, this is cube, right? Here it'll be plus times minus, again it'll be minus. So we will already have minus, and this minus will be plus 2/3, and over here it'll be minus minus, again plus 1, and lastly we will have minus c only. So the c and c cancels. You will have 2/3 2/3 and 1 and 1, so it'll be 4/3. That'll be 3 1/3. Okay, you can just put in the calculator, you'll get the correct answer. Okay, so this is over here. See, my answer is wrong, sorry. No, that is this one B. Let me just check. Yes, it is 3.313. This is 3 1/3. Yeah, I did the calculation correct, but please use calculator, do it properly. This 3 1/3 means it's 10 by 3. That is 3.333. So that is how we solve it. Now this is also writing method itself. Technically you can write this, but it's very small. So if you're finding this to be, if you're finding, oh, this is very small and everything, you can just go with the proper method. Okay, but this is the definite integral by writing method. So don't just do in the calculator. Please try to write something. I'm just doing this as a backup method. If you forget it entirely, try to do this. So please try the other problems. All the solutions are over here. It's very simple. The concept remains the same. The formula is the same. All you need to do is use the formula, find delta x, find x of I, substitute in the formula, then you substitute back and do it. Also, you can in the middle, you can directly try substituting the values over here, the formulas, and then you can take the limit by calculator as well over here. If you're thinking how to take the limit, we have done it before. Infinity means just substitute a huge number here and you will get the answer. So this is also another thing. This part, I mean the limit part, directly do in the calculator. So that's it. If you want this presentation, you can click the link in the description and you can find the presentation. So this is all the answer solutions. I hope that has been helpful. Please try to solve all these problems by yourselves. The concepts are same. It's a easy topic. Please solve each and every problem. Try to practice thoroughly so it'll be very easy and you're very fluent with it. I'll see you all in the next video. The question 20 is on definite integrals. This is one of the easiest in the writing part. So the problems are very simple. Now I'm sure this may not come for your exam. You will get a bit complicated one, but let's start from the basic one. When you have integrals like this definite integral, and this is the given equation, and you have been told to find the derivative, f dash of x. You just have to substitute the upper limit. Apply the upper limit, that's it. If you're thinking why exactly, but if you remember, now say you derive something. Let me derive x cubed. The answer is 3x squared. Now let's integrate this. Integrate 3x squared. This will be 3x cubed by 3 cancels off and you will have x cubed, right? So they are inversely proportional. I mean, see, the integral of anything must be, it's originally the derivative of that function, right? So it's kind of like that. So now over here, you have to find the derivative. This is integral thing, right? So all you need to do is leave this function as it is because that itself is its derivative. But all you need to do is substitute the upper limit. Now what happens over here is whatever is with respect to t, right? Just substitute the upper limit, it'll become x squared minus 3x plus 2. That's the answer, that's it. No plus c or anything because it's derivative. Now even over here, if there is any constant, any number, it goes off. Okay, so it'll be instead of t squared, all you need to do is x squared minus 3x minus 4. Now, what if you have something more than x? Now, this is not just x, right? It's more than x. So, let's use the same concept. E minus x, t becomes x squared. Then there is one more square over here, right? So, this t becomes x squared. That's it. That's the first step, plus 1. This much is done. Now, what you need to remember is you need to multiply this entirely with this derivative. The derivative of whatever, it's more than x, right? You need to do its derivative. Even over here, you basically derive it. What is derivative of x? It's 1. So we just leave it. Okay. So over here, it'll be 2x. So now what happens is 2x will be multiplied here. It'll be 2x e to the power minus x to the power 4. 2 times 2 is 4 plus 2x. This would be the answer. Now what about over here? Here, see, you should not have a number here. You should have the variable up. Now you have a number must be down, that goes off. But what you can do is you need to swap it out. You need to swap, this becomes x, this becomes 2. It'll be secant t dt, right? But what happens when you swap this? You need to add a negative sign. This is the actual way to do it. When you want to swap the limits, you need to add a minus sign. Now don't go to do anything, no integration, nothing. Minus remains. It'll just be secant x dt goes. So this is the functions. You can see the answers are so simple. It's x squared minus 3x plus 2, x squared minus 3x minus 4. That is what we also got. And over here, now they have not multiplied this 2x inside. I've multiplied it for both the sides, but it's fine. If you're keeping it out, it's also fine. See, 2x is out. E to the power minus x to the power 4 minus x power 4 plus 1. It's fine. Minus secant x. So this is the thing. But what if you have a little bit more complicated, two terms up and down? Now, imagine you start from your home, okay? And you have to go to school over here. So this is your starting destination and this is your end destination. But you stopped over here. Say you stopped at a gas station to fill gas. This is a point where you stopped. But then you continue and reach over here. So this doesn't matter. You ultimately started here and your end destination is the school itself. Now, same way you can consider this. You can break this into any number of points. But remember, from your home, you stopped over here. But then from here again, you go over here. The stopping can be dissolved. So what you can do over here is the limits e to the power x, you can split it out plus as long as it ends over here. So you can stop anywhere. Let's stop at 0 and 0. You can stop it at 2 and 2. It's fine because they will anyways be dissolved, right? They'll go off. So this is how we can split it out. Over here, what happens? It'll be sine t squared dt. Here also it'll be sine t squared dt. Now here we cannot have the number up, so let's write minus integral e to the power x. Over here it's 0, it will be sine t squared dt, plus over here you can directly apply over here, there's no problem. It's 0, it is sine t squared dt. Now what do? Instead of t, all you need to do is substitute the e to the power x. So it'll be e to the power x the whole square and multiplied by e to the power x, because we need to derive this. It's not just x. That's it. Over here what happens? It'll be sine 2 minus x the whole square, and what is derivation of 2 minus x? It'll be minus 1. So when you simplify, it'll be minus e to the power x sine e to the power 2x, because I just multiplied 2 and x, plus it'll be minus, why? Because minus times plus is minus, sine of 2 minus x the whole square. So this is how we can easily solve it up. The answer will be that. It's the exact same answer. Sometimes your answer may be in a different form. The answer will be correct, but it's just in a different form. That's fine because it's writing. If you write so much, it's more than enough. But if it's the MCQ part where you have 4 options, just try to rearrange and check for the options and you can write it out. So please try to do the other problems by yourselves. Over here, please remember it'll be a product rule. Okay? Yeah, it's clearly mentioned over here. This product rule will be there. Why? Because you need to derive the second part, right? When you derive this, it'll be a product rule. Very simple. Please try these problems by yourselves. All these are worked out over here. This concept remains same. When you have two functions up and down, first split it out and then swap this up, take this x square up, 0 goes down and it becomes minus. See the minus sign. And over here what happened? It became, instead of t, it became x square, and then you need to derive this. Okay, over here they have written d by dx. I was writing it directly with derivation. I reduced the steps, but as long as this is all right, because we know this is all basic stuff, so you obviously know it, so you can directly write this. That is how we solve it up. That is the end of this 20th question. This is the last question in the exam scheme, but we have not yet done the explanations for the previous videos. I will try to do them very soon. And before I finish, a quick reminder to all of you, if you're finding these videos helpful, please do share it with your friends and also do consider subscribing to my channel. See you in the next video.